Today I'm working on one of the most important structural components of the wood, the neck block. This block connects the neck to the bowl and helps define the transition between the two. It looks kind of like a simple piece of wood, but there are several important design decisions behind it, and I'm going to explain what those are and also share the construction process. So here I'm carving out the initial shape of the neck block using a chisel. In the past, I've used a rasp at the start of the process, and it never worked out for me as intended. I prefer carving the initial shape using a chisel, and then later on moving on to a rasp and sandpaper to do the final shaping and smooth out the neck block. So here I'm using a rasp to give the neck block its final shape. I have the neck block attached to a jig that I built. The jig profile matches the wood bowl profile, and it gives a fairly accurate visual reference. Also, the neck joint surface, I've left it as a semicircle. I do plan to flatten it. Here I show the neck block construction process. Geometrically, the neck block, it starts as a rectangular billet, and then it is shaped into a three-dimensional curved wedge, which is defined by the inner bowl profile. Okay, the shape of the neck block, it resembles half of a conical frustum, but in reality, its final geometry is defined by the instrument's inner bowl profile. Okay, so that's per the design. So starting with the billet, which is step one, design the block, and I will share additional details on this entire process. What I like to do is I cut the rectangular billet into a semicircle. That's my starting point. I've tried different approaches, but this particular flow has worked the best for me. Okay, and there's different approaches, but this is what I use. So after I cut the semicircle, I cut the sides following my profile lines. Okay, then I carve the block, and then I use a rasp to give it its final shape, and then use sanding to smooth it out. On the right side, I highlight the neck joint surface, which I've left in this example. I've left it as a semicircle. I do plan to flatten it. Okay, on the bottom right, I show the rib glue surface, and then on the extreme bottom right, I show the block thickness. And I'm going to talk more about the block thickness and its implications, from a design construction perspective. Okay, this particular example, the block thickness, my block thickness is 37 millimeters, right? And all that's the distance from the neck face into the bowl, right, along the center line as I show on this image. So here I look at some of the design decisions, okay? The neck block is a key structural part of the instrument. It's carrying the string tension through the neck, compression from the bowl, and the glue surface from all the ribs, okay? So it starts with the inner bowl profile template. I like to say in image number 3, 4, and 5, I show my inner bowl profile template, and then I just build a small neck profile template. It makes it easier for me as I am building the neck block and the jigs and other items supporting the OOT build. Okay. The first design decision is already built into the template itself, okay, which is the neck width, which I show in image number 3. Okay. Once the bowl profile is established, so you got your inner bowl profile already created, the block depth, so the depth of the neck block, it follows directly from that geometry. Okay. Now I showed in the earlier example, and also here I'm showing in image number 2, my initial neck block depth I selected was 37 millimeters. Okay. So a shallower block, it will create a more abrupt transition, and this is what I learned, right? So it will create a more abrupt transition from the neck into the bowl. While a deeper neck block, it spreads that transition over a greater distance and it creates a more gradual slope. Okay, and there are certain trade-offs, and I'm going to talk about that. Okay. Now in image 4 and 5, I just show the neck profile template that I built, and it matches exactly. It has to be fairly accurate. Okay, it has to match exactly your inner bowl profile template. Okay. So now if you look at image 6 and 7, it's going to get more clear when I talk about the shallow and the deeper neck block decision. So just looking at some of these dimensions, you start at station 0, which is the starting point, right? Which is the neck joint, okay? So that depth is 22.5 millimeters. And as you go, so if you look at image number 7, it's going to get clearer. So what I'm showing, I'm holding my neck profile template, and I've got that sample block on top, right? My first block on top. So as you see, the starting point is station 00, which gives you the depth of the, so when I say the starting station, you just go along the horizontal where my thumb is, okay? So it gives a depth of 22.5 millimeters. And as you go to higher stations, you will observe that the bowl is deepening very quickly near the neck. Okay, so if I move the block to station 45 from 37, it spreads that transition over about 22% more length. 50 millimeters spreads it over about 33% more length, and 55, 50% more length. So my initial block was 37, but I'm evaluating for this build, I'm evaluating a final depth of somewhere between 40 to 50 millimeters. Okay. Now here are the trade-offs. If you go with a shallower neck block, it is lighter. It is, but it has a more abrupt neck to bowl transition, which makes it a little difficult. It provides less gluing surface for the ribs, right? And then it also has less material around the neck joint. You go with a deeper neck block, it's heavier, but it provides a more gradual neck to bowl transition, which is preferred during construction, okay? It has more gluing surface for the ribs, and then more material supporting the neck joint. And I've seen, so the Nahat woods, right? They use small, very shallow blocks, like 37, 38 millimeters. I've seen builds with much heavier blocks, and like I said, I'm just in the process of evaluating. I think it's going to be somewhere between 40 and 50 millimeters depth for my build. So once the geometry of the neck is established, we shift our attention to wood selection. Okay, and there's an entire science around wood, and inshallah, at some point, I will capture it in an episode. Where I live, I'm blessed. I'm surrounded by beautiful hardwoods. So that gives me an opportunity to experiment with different varieties. For this conversation, I have captured a few of the more commonly available woods for neck block as well as the tail block for that matter, right? That I have access to. Okay. So one of the before I go into additional details on what I'm presenting here, it's important that we understand that when selecting wood for the neck block or the oud or for any project for that matter, right? Stability of the wood and the grain quality are more important than finding a perfect piece of lumber. Okay. In that table that I show, I have selected a few options that I am considering for the oud neck block, and as I said, even for the tail block, starting with spruce. So the second picture I show in the middle, where I have one of my neck blocks that I'm holding, that is spruce. Okay, and that is an excellent choice for a neck block. And I'm not going to read through the properties, but it's captured here. Okay, but that spruce is an excellent choice. You know, the stiffness to weight ratio, stability, and the workability, right? It's excellent. It's a very easy wood to work with. On that same picture, right, the one in the middle, that billet, that's Western red cedar. Okay, so that's another pretty good option for your neck block. Okay, then the third picture going clockwise, I show, just for comparison, I show hackberry, which is diffuse porous. So that's a billet of hackberry. And right on top, I show a log of ash. Okay. Ash is ring porous, hackberry is diffuse porous, but not ash, but hackberry. It's one of the softer hardwoods. And absolutely, it can be considered, it's a joy to work with. I mean, this hackberry billet is from my property, same as that ash, but that hackberry is a joy to work with, right? So, but that's another option. And one last one I would consider is yellow poplar. It's called poplar in the part of the world I'm in. In other parts, it may be known by tulip poplar, maybe. But that poplar is another very good option for the neck block. Okay. Now, this Western red cedar, the billet I'm showing in the second image, this actually came from a pergola at our home, right? So I show that pergola on the bottom picture, right? Now the pergola, this wood has been sitting there for almost at least 25 to 30 years, right? And it's been part of our home. I had to make a decision last year to take it down because the cross beams were compromised for different reasons, right? Although at that time I had no specific project in mind. I love wood and I saved it for a future project, although it was a lot of work. And then over time, I cleaned the boards, I removed the nails and the hardware and set the wood aside. And only later, when I started building the sood, I just planed a few pieces and discovered what was hidden beneath the weathered surface. It was remarkably straight grain, tight growth rings, and beautifully seasoned cedar. So even after almost, I want to say, gosh, 30 plus years, this wood is in excellent condition. Okay. And I'm planning to use it. That's my top contender for the neck block, as well as the tail block. Okay. So I have a lot of these cedar boards, and they are, some of them are quarter sawn. This one in the image I'm showing is rift sawn. And then in that pile, there is some that are flat sawn. But the quarter sawn ones and even the rift sawns are the most valuable to me for this oud project. So another important consideration when selecting the wood is grain orientation. Okay. Now, wood is strongest along the grain, and which is why the grain orientation becomes an important consideration, right? And by aligning the grain with the direction of the string pull, the neck block would carry the load through the fibers, to the wood fibers' strongest direction. Okay, if you look at that second image that I'm showing, notice that the neck block, the grain direction is going horizontal. Okay, not that that will not work, but that is not preferred. Okay, all right. Now, if you look at that cedar billet that I show, and if I was to carve out my neck block along the grain, that would be the preferred option. Okay. But again, instrument building or any project is always a balance between, an ideal design and the materials that you have available. And sometimes the best solution is not a theoretical one, but one that makes the best use of what you have in front of you. Okay. So if I have to align that grain direction in the preferred orientation, again, not saying that the horizontal will not work. There's many woods neck blocks that use horizontal. But if I was to do that, there's additional work I got to do. So with this cedar billet, which I show in the center image, so I have to laminate that cedar billet that I'm showing in that center image in the top row. Okay, that thickness is about 38 millimeters. Okay, and if as I pointed out, I'm planning to consider 45 to 50 millimeters, so I have to laminate it to increase that thickness. But if I want the orientation of that neck block to follow the grain, along the grain, then I also have to laminate on the edges. Okay. So at this point, I haven't decided how much additional work I want to put in creating that perfect billet versus just using what I have available. Okay. And in the next episode, I will finalize the neck block. So this neck block that I showed in this episode, it is kind of a smaller block. But in the next episode, I'll finalize the neck block dimensions based on my requirements or my adjusted requirements. I'll prepare the material and begin shaping the neck block, and I will capture it. And if all goes according to plan, using that cedar from the pergola, a piece of our home's history may soon become part of the suit. I look forward to seeing you in the next episode.